Okay, so now we are at section 1.8 and we're looking at applications of the linear equation. And I think section 1.9 and also section 1.10 are about applications. And applications is simply another way of describing what you have heard of as word problems. And generally, students have a little bit of an adverse reaction to word problems. And what I'd like to do is offer up a strategy for you that will help you approach these and solve them with some confidence. So the strategy that I think you need to follow, I'll show you below, and I'll try to follow that strategy in solving the word problems that we'll be looking at in the next 3 sections. So here it is, and there's 6 steps that I have here. Let me just go through them with you. You want to read the problem enough so that you understand the key ideas and so that you can, without looking at the question or the problem, just turn to a classmate and give them all the pertinent information, especially what the question is. And that's part 2. You really need to make sure you understand after you've read this exactly what it is you're looking for. And once you have determined what it is you're looking for, then you want to assign a variable to that expression. And even though I know that it's kind of common to use x, it makes more sense to use a variable that's a little bit more descriptive. For example, if you're looking for how old Jack is, then instead of using x, use J to describe Jack's age. What you do then is really the heart of the problem. You take the English statement that you're given and you translate it to mathematics, and you write and you solve that equation. That's the hard work. And if you haven't done these things, you probably won't be able to do number 4. Once you've solved that equation, you want to make sure you check it, and also make sure that the answer is reasonable. And then finally, because you were asked a question in a sentence, you always want to make sure that you answer the question in a sentence. Okay, so that is the strategy. It's an important strategy, and it's one that you should kind of come back and look at from time to time. Okay, so here's our first example. So we read it a couple of times, and we recognize that we're looking for some number. And so it makes sense that we're going to call that number some variable, and let's use n equals the number. And now we have to take the English and translate it into mathematics or algebra. So 5 is subtracted from 3 times a number. Well, 3 times a number is that, and we're subtracting 5 from it. And the result is equals 10. So that's the real important part. We're subtracting 5 from 3 times a number, and the result is 10. So now we solve this, and you should be able to solve this pretty quickly. And if we solve it, we get n is equal to 5. And so, as you were told, the number is 5. Okay, let's look at some more. Okay, so read this one a little bit, and you'll see that it's similar to the other one, asking about numbers. And so now we have to figure out what the question is, which is, what is the number? And we have to take the mathematics, the English, and translate it into mathematics. So if we do that, what we see is 60 more than 9 times a number. Okay, so we'll begin by letting n equal the number. Always want to have a let statement. 60 more, that means adding 9 times a number. So 9 times a number plus 60 is the same as, that means equals, 2 less, that means subtraction, than 10 times the number. 10 times the number minus 2. Okay, so there is my mathematical statement. And again, if I solve that, I get n is equal to 62. And so finally my answer is, always answer in a sentence, the number is 62. So notice here, I'm not going through the steps to solve that equation. At this point, we've done a bunch of those problems. You've done more, and you should know how to solve them. But if you do solve it on the side and you get something other than 62, either you've made a mistake or I've made a mistake. Alright, so take a few seconds and read this problem. We're looking for 3 consecutive integers such that blah, 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 blah. But 3 consecutive integers. So the way that we do that is we say, let the integers be, well, the first one will be n, the next integer is n plus 1, and the next one is n plus 2. So those are 3 consecutive integers. And now I have to translate the English into mathematics. So the sum of the first plus twice the second and 3 times the third is equal to minus 76. So I'll do a little bit of the mathematics here. We have to write this as n plus 2n plus 2 plus 3n plus 6 is equal to minus 76. So if I simplify here a little bit, I'm going to get 6n plus 8 is equal to minus 76. And if you go ahead and solve this, you should get n is equal to minus 14. It's an important intermediary step. And so, the integers are, well, the first one is minus 14, and then I add 1 to that, and I get minus 13, and I add 1 to that, and I get minus 12. And there is my solution. So in order to do some of these problems that we're going to be dealing with in terms of geometry, you need to recall that the sum of the angles in any triangle will always be 180 degrees. And most of the problems that you're looking at use that fact. So let's look at an example. So we need to read this carefully. The second angle of a triangle is 4 times the first, and the third angle is 5 degrees more than twice the first. Find the angles. So each of these is defined in terms of the first. So it kind of makes sense to say, let's let A equal the first. Now the second is 4 times the first. So 4A equals the second angle, and finally the third angle is 5 more than twice the first. So twice the first plus 5 equals the third angle. And so now I have descriptions for each of these angles. And remember, what I know is they have to add up to 180. So the first angle plus the second angle plus the third angle has to equal 180. So if I simplify this, what I get is 7A equals 175, and that means A is equal to 25. So therefore, what I need to write is the angles are, okay, the first one is 25. The second angle, remember, is 4 times the first. So the second angle is 100 degrees. And what's the third one? 2 times the first plus 5. Well, 2 times the first is 50, and 5 is 55. And so there we go. And check it out. They will add up to 180, and they satisfy the relations given. Kind of fun. Alright, this will be the last one that we'll look at, and we need to read it a couple times. And so what we figure out is the horse is 4 times as much as the saddle. So let's do this. Let's let S equal the cost of the saddle. That's why I chose S. And the horse is 4 times. So 4S equals the cost of the horse. Okay, so now I have variable expressions for each of those, and I'm told that combined they cost 5,000. This is pretty simple. S plus 4S is equal to 5,000. So that means 5S is equal to 5,000, which means S is equal to 1,000. Okay, important intermediate result. Let's put a box around it. Let's answer the question. The saddle costs $1,000 and the horse costs how much? 4S, $4,000. Combined they add up to 5,000. So there you go. See you next time.